Good afternoon, everyone. Thank you so much for joining us for the first webinar in our webinar series, Conducting Effective On-Farm Research. My name is Abby Augarten, and I'm joined today by Jerry Clark for our first session on Farm Research 101, From Hypothesis to Harvest. So in today's session, I'll be starting us off with some on-farm research fundamentals, and Jerry Clark will follow with some practical research approaches to on-farm research. I work for UW-Madison Division of Extension. My name's Abby Augarten, and I support statewide efforts in agronomic on-farm research. So, agronomic research in general is really valuable as it provides credible information that can shape informed management decisions that ultimately support economic viability and environmental protection of our production systems. And we have agricultural research in a couple of different forms, right? So we do have our UW research stations. This here's a photo of Arlington, and you can see all of those small plots laid out there. And research stations are a great place to, first ask and investigate agricultural research questions. It's a great place to control as you implement these trials to ultimately try to reduce as much variability and error that we might get entering the trials. It also is a great location to ask long-term and complex research questions that might just be logistically challenging to implement in an on-farm setting. It's also a great place to test riskier questions where we're uncertain about the outcomes and there could be some economic and productivity consequences of those trials. However, we recognize there's limitations, right? We have a diversity of soils and systems and landscapes here in Wisconsin. And though we do have research stations throughout the state, there are limitations when we're trying to really inform management across a diversity of systems. Which brings us to the value of some on-farm research. So this is research conducted on farmers' fields for their specific soils and systems and with their equipment. Here we're looking at a photo of a on-farm nitrogen rate study that was implemented. And here, the value is twofold. So the one is it's a great opportunity to really test and evaluate farmer-specific questions and interests. So whether it's practices or products that are being recommended from industry or from UW or other sources, it's a great opportunity to test those practices, evaluate if it really works or doesn't work for this particular farm, and be strategic, right? Test it in a safe space before scaling up. We can also collect a lot of local data that really can inform regional management decisions and create, localized sources of information. In particular, too, as we collect more and more data, both from research stations and from on-farm trials, we're able to capture a lot of information from a diversity of systems and growing conditions, which really amplifies how quickly we are able to learn about how certain practices may play out on the landscape. We've been also seeing an increase in on-farm research a lot because technology has advanced in ways that have improved the ease that we can implement on-farm research trials, right? If we think about yield monitors and some of the GPS systems and variable rate technologies, all of these could be tools to improve how easy or challenging it is to implement some research trials. Though, these sorts of technology aren't required for any sort of on-farm research trial, and there's a lot of different approaches that we can go to implement on-farm research trials using the resources that are at any given farm. So really wanting to dive into how on-farm research can be a tool for particular farmers to inform their decision-making on-farm. In my session this morning, I'll lead us through the process of, developing and implementing a research project. And again, with the goal that a given research project will really be of value to the producer, we want to develop a research question that targets, the interests and needs of that producer. That leads us to developing a research design, implementation and data collection, analyzing data, interpreting results, and then ideally repeating the trial. We know that no two growing seasons are the same, so it's really valuable to repeat trials across a diversity of growing conditions. So today we'll walk through some of these steps with an emphasis on developing the research question and research design. And I do want to highlight that, on-farm research can be challenging, and really working with trusted advisors, whether that's folks at the county level, at UW Extension, or an agronomist, is really valuable, and ideally even working together. And us at UW Extension are always available to support farmers and partners as they explore potential on-farm research trials. So let's start with developing a research question. I was chatting with one of the farmers I work with the other day, and I was curious about some of his interests, and he expressed he was really curious to figure out how to fine-tune his cover crop management in order to ultimately, improve his bottom line, improve his corn yield, as well as maximize environmental benefits. But right, this is a pretty lofty question, and as we continued chatting, a few things popped up. He was interested in looking at cover crop species, as well as cover crop seeding rate. Then also curious how termination timing might influence these factors. Adding on a level of nitrogen rate to see if we could try to reduce the likelihood of a yield drag at certain higher nitrogen rates. And then he said, well, I haven't really investigated any, other nutrients and micros as well. So maybe sulfur and zinc and manganese and so on. And for anyone, keeping score at home, this is many, many, many different treatment combinations. And if it were employed on farm, right, this could easily be hundreds of plots. So it really, emphasizes, while there's a lot of enthusiasm and excitement about all of the different things we can investigate, the importance of really honing in on a research question. So when developing a research question, I like thinking about what do we already know, right? What information and resources are already out there from other local and relevant research studies, and how can we use this to inform, whether or not an on-farm research trial is the next step, and if so, what really should we investigate so that the farmer gets the most bang for their buck. Next is thinking about questions that are valuable to the farmer. So in my previous example, right, the producer I was working with was interested not only in yield and profitability, but was also really interested in the environmental outcomes. So thinking about, right, what is the research question? What are the outcomes that are of value to the farmer? Trying to be as specific as possible to really guide us in the next steps of developing the project, and keeping it simple, especially if you're new to on-farm research. It's really easy to get caught up in thinking about all of the different questions that we can ask, but this amounts to a lot of work. So thinking through simple research questions is going to be key. And next, thinking about the feasibility. So what equipment does the farmer have? What are the resources available to us and resources that we would need? And what are, the requirements of potential field sites, and do we have that accessible? And then really using this research question as your guide. So from your research question, developing what your hypothesis is, so what you expect the outcome to be of this research trial and what you'll ultimately test with statistical analysis, then developing your treatments and what measurements you'd like to measure throughout the trial in order to really tackle your research question. And this leads us to, setting up a trial. And I really think setting up a trial with confidence. On-farm research trials can be a lot of work, and the worst outcome would be putting in all of that work, collecting all that data, analyzing it, and thinking, well, something fishy happened here, and I don't really know if I can trust these results. So really thinking upfront about what you need in order to have confidence and have that ability to inform decision-making at the end. So ultimately, the goal being to discern if differences in yield or whatever other outcomes you're interested in are attributed to the treatments and not other random factors like variability, error, or chance. And one of the challenges with this, right, is that agricultural fields are inherently very, very variable. So we could have variation in soil type, in drainage, in field history, and topography and slope, differences with pesticide residual, or even with planting error or cover crop seeding error, or things like deer grazing. So the opportunities for variability are quite robust in our agricultural field. So especially with on-farm research trials where we have field scale or large plot designs, we know we have a lot of spatial variability that we need to be cognizant of. So there's two opportunities here to address some of that in-field variability and set us up with confidence. So one is being mindful of field selection, right? Understanding the potential sources of in-field variability and then setting us up to try to reduce those sources. And this can be where, historical yield maps can be really valuable, or even just, anecdotal reflections from the farmer about, oh, this area of the field always tends to be a low spot or tends to be wet, or, we used to always put manure on that side of the field. Things like that are going to be really important. And then the next big category is the research design. So we do have an opportunity with our experimental design to set us up for success and try to minimize unexplained variation in the data, which will be huge at the end of the season when we're running statistical analyses. So before I go into experimental design a bit further, I wanted to, pause and kind of go through the glossary of terminology that we're talking about. So bear with me for a bit, but right, we've been talking a little bit about treatment so far. So those are the individual things that you are testing. And with that too, we really like seeing a control or a check, which is a specific treatment that serves as a basis for comparison. So let's say there's a new fungicide product out there that you want to test. That the new fungicide product would be one treatment, and then your control and checks and other treatments to include would be, right, a no fungicide check, and maybe your current fungicide as a good comparison. So ending up with 3 treatments. And here in this plot map here, we can see that each treatment is outlined by a different color, and A, B, and C. So the next term is plot. So that's the physical area that treatments are applied. So in this case, each one of these strips is considered a plot. And then experimental design is how those plots are arranged. Then replication is the act of applying each individual treatment to more than one plot. So in this diagram here, right, we have each treatment is replicated 4 times. And then blocks are the physical grouping of treatments. So, right, each block here consists of one replication of each of the 3 treatments. You might often hear the words replication or rep and block used interchangeably. There is some nuance here, but both of them are reflecting back to this core idea that we, have groupings of replicated treatments here. And if you do have a field with, with any variability across a gradient, so let's say your soil type is changing, or soil moisture or slope, setting these blocks up so that you're perpendicular to that gradient is going to be really key to minimize that unexplained variation. So essentially you want within any given block to reduce the, potential variation among the treatments from unexplained sources. And then the last term is randomization. So putting out these treatments with no discernible order, right? So we want it to be in a random order just in case we do have that source of variability across a gradient. We don't want to accidentally be favoring one treatment over another. So the next thing I want to talk about are some simple approaches to evaluating practices. The first one is surveys, or more, unstructured forms of data collection. We have a few great survey projects happening throughout the state that are designed to evaluate things like cover crop biomass, soil health, insect counts, and so on. And the intention of a survey is a little bit different than what we've been talking about so far. So here a goal is to gather a lot of data, hundreds of data points across the state or whatever your regional area is. And with that, collect all of the background data, the inherent properties, your management, things like that, so that we can reflect and look more at what sorts of trends are in the data set. Do we have benchmarks that we can use, and so forth. So it's a really cool approach to collecting a lot of data and learning neat things when we come together. In the last webinar of this series, there will be a project that's touching on or that used a survey approach. So I wanted to give a little bit of background today. But other sorts of research approaches that we commonly see are things like paired fields, where you have two different fields with two different treatments and are trying to assess whether or not, the two treatments perform differently. Or a split field where you have a field and you divide it in half, each half getting a separate treatment. So while these are, easier to implement, which is why we tend to see them more often on the landscape, there are some concerns or cautions to have with this sort of research approach. So the first, if you notice, comparing these sorts of designs to what we saw on the previous slide, these are unreplicated designs, which means that when we do have in-field variability or error or wacky events that happen throughout the season, it's really hard to, tease apart what was truly an effect from the treatment and what is an effect from other sources of variability and error. So it is something to be cognizant of and cautious when using these approaches. But that being said, there are things that we can do to at least try to set us up for success as best we can. So, right, this goes back to really thinking about selecting field that is as uniform as possible, selecting your layout, how you're splitting the field to try to minimize or spread out potential sources of variability across the treatment, taking more subsamples from within those two treatments to try to get replication in that way. So just some things to consider, and happy to chat through more of those considerations for folks that are trying to figure out a way to make this sort of system work. But really what's a lot valuable is having replication and randomization in your research design. So these more robust approaches are going to be what gives you the confidence at the end of the season to run that statistical analysis and tease out what was an effect of the treatment and what was just other error and variability that we see in the field. So there's a few different experimental designs that include replication and randomization that we commonly see in agricultural research. Just to throw more terminology at you, but we won't go too much in depth into these. One is a paired comparison where you're comparing two treatments. The next is a randomized complete block. So that's what we see here in this diagram where we're comparing 3 or more treatments. And then the next is a split plot design. So evaluating how different management factors interact. So we would layer on, right, 2 different sets of treatments, such as cover crop species and termination timing. And, what's really valuable too statistically with this sort of design when we have our blocks set up across a gradient of variability is when we're running our statistical analysis, we can figure out, what effect did we see from the treatment? What effect did we see from the block? Right, so let's say we have a moisture gradient here. Maybe we saw a difference where it tends to be wetter or drier, but we can also see any potential interaction effects. So maybe a certain treatment performed better in those wetter areas and a different treatment performed better in those drier areas. But we know that this is more of an undertaking, right? It can be logistically more challenging to implement on farm. There are certain treatments or technologies that can make it easier, but there are some things like, manure application rate or application method or planting date that might be more cumbersome to implement in this replicated and randomized fashion. But something to definitely consider, again, so that we could feel confidence at the end of the season. So to explore a little bit more the value of replication, so here we're looking at some nitrogen rate data from the Nitrogen Optimization Pilot Project, which is a DATCAP funded project, and UW Extension and UW-Madison are helping on the research design and implementation side. And we're looking at just the data for one farm. Here on this field, they had 4 different replications of 6 different nitrogen rates. And we see nitrogen applied on the x-axis and yield on the y-axis. And we're looking right now just at block 1 data. And right, if I were looking at this data, I see, okay, well, we hit our max yield at around 140 pounds of N per acre, and then we have a plateau, right? And at those higher rates, we're putting on more nitrogen, but not getting any yield benefit, which means that's going to hurt, economically and environmentally. But now let's look at the next block. And right, we see a completely different story where we reach our max yield at around 230 pounds of N per acre, and we never quite plateau. So, we could argue that maybe we even could have gotten more, right? Maybe we could have gotten more yield if we put on nitrogen. So that's nearly a 100-pound difference between those 2 blocks, right? And this just really highlights, now we're looking at all 4 blocks, the value of replication. And now from here, we have, right, more statistical vigor, and we can run the appropriate models to figure out what that optimum nitrogen rate and with what sort of confidence we have in that. So typically we recommend 4 to 6 replications. I'd say at the minimum, you could get 3 in there. That would be great. So that way, if something wonky happens, you have, 1 replication to spare. And just some final considerations on the experimental design front. I really try to promote simple and replicated is going to be greater at the end of the day as compared to complex and unreplicated. Again, there's nothing worse at the end of the season of putting in all that work and looking back and still be scratching your heads. So, that's one consideration. The next is that really creating the plot layout, plot sizes are going to be dependent on the specific question, the field, the equipment. So working through all of those logistics is key, and really helpful to, come together. The farmer, folks at Extension or agronomists or the county, whoever's involved, and work through all of those details up front is going to make for a more effective implementation process. Which brings me to collecting data. I think most importantly, right, having good records of all field management practices is really key. This includes planting and harvest dates, hybrids, plant populations, tillage, all of your inputs like fertilizer, manure, herbicide, and so on. I do often get asked like, well, if I'm just comparing 2 different cover crop species, for example, why do I need all of this other information? And I think, this is the importance of context. We know that all of these different management practices can interact. So really at the end of the season, it's valuable to not only know, right, what was the treatment effect on yield, but why did we get there? What sort of potential, right? How does the field management with the context of that season play into the results that we saw? And I think especially if you're collecting data across multiple fields or from year to year, these sort of field management records are going to be key contacts for that. Then we have different field measurements. Again, keep it simple and let your research question guide you. It's really exciting to try to measure everything, but especially when we have, right, field scale research projects where plots might be really large, all of a sudden it can be quite a lot of labor and time and money to try to measure everything across something of this scale. So trying to keep it simple. I definitely recommend having a recent soil test, right? Having yield, and then other sorts of measurements that you can add on as it relates to your research question. And then lastly, photos, observations, and notes are all really important, especially, trying to do some scouting and check in on those trials throughout the season, taking note of anything wonky that's going on, whether it's a low spot or a pest outbreak in a certain area of the field. All of this will be really important at the end of the season to reflect back on that yield data or whatever other measurements or outcomes you're evaluating. Next step is data analysis and interpretation. So We do use statistical analysis to determine, right, the likelihood that any difference in yield or other outcomes can be attributed to the treatment. This entails doing some data cleaning, especially if you have any spatial data like yield monitor data. Doing some cleaning on that's going to be crucial. Next is, the statistical approach is going to be based on the research design itself. We do often see for those paired comparisons a t-test, and for the other approaches, we'll use ANOVA, and we significant differences. So those might be things that you see or you notice as research is being reported and presented. And we're not going to dive too much into both of those, but if anyone wants to know more about that and it would be beneficial to have another session diving into the statistics, please let us know. And next is interpretation. So again, evaluating all of those results within the given context of that growing season and what it might mean from a management decision. And then working collaboratively to look at treatment effects across a broader scope, right? The importance of multi-site and multi-year work is really valuable to get a broader understanding of how that specific management practice might vary across different growing conditions, geographies, soils, management conditions, and so forth. And then the last step is sharing results and connecting with others. I know we get huge value learning from one another, farmers especially. So sharing those results at field days, at workshops, or within producer-led watershed groups is going to be really valuable. And with that, I will pass it off to Jerry to pick up.
All right, thanks for joining, everyone. My name is Jerry Clark. I'm a regional crops and soils educator for the Division of Extension with UW-Madison, based in northwestern Wisconsin in Chippewa, Dunn, and Eau Claire counties. And just a little background of being asked to kind of provide a little more on the practical research approaches. So Abby did a great job of talking about what the design looks like and all the different pieces that go into it. And I'm just going to provide more of a hands-on approach or some things that can maybe help to think about as we move forward, putting a on-farm research project on the ground. So we've done quite a bit of local on-farm research here in northwestern Wisconsin, specifically in the 3 counties I work in. And so over my career, I've been with Extension about 27 years, and we've done several different types of projects with different crops, whether they're more the common field crops like corn, soybeans, and alfalfa, but we've also done some work in specialty crops like hops and industrial hemp, and then some of the small grains. And then looking at some of these different projects that might be a little more interesting from a methodology standpoint of interseeding alfalfa into corn silage, these kind of things that we start to think about some different methods that we might want to investigate. So that's just kind of a laundry list of different projects that we've done here in northwestern Wisconsin related to the different crops that we've had an interest in. So the way I'm going to approach this topic today is in 3 kind of segments. We're going to talk about thinking ahead a little bit. So what are some things you need to be thinking about, or to from that practical standpoint, how we can make this on-farm research the most impactful, or at least, like Abby said, simple, that we can get the results we want as we come up with those questions that we want to answer. And then implementation. I think that's sometimes can be the easiest part. If all that thinking ahead and what you want to do, and then you've got the right farmers working with, or if you're doing it yourself, how the implementation part, if you're set up with all your notes and plans and what you want to collect and those kind of things, you can actually save yourself quite a bit of time on implementation if you're thinking ahead far enough. And then finally, some resources to think about as you get closer to either getting the data collected or throughout the growing season as it gets implemented. So we'll break this little presentation up into those 3 segments. So kind of what Abby was referring to is thinking ahead. What is the question you want to answer, or what do you want to find out? And then how are you going to get there? So I think if you can look at those three questions as the question that you really want to answer, maybe it has something to do with a new piece of equipment that you've used or some kind of method or a product. But whatever that question is, that does this really work, or is this increasing my yield, or is this just costing me more money? What do you want to find out in the end? And so thinking ahead a little bit on these types of questions can help you at least frame what you're trying to get at. And then finally, how are you going to get there? Think about it as what do I need to do to put this on the ground is one thing, but then thinking about how am I going to collect the data, how am I going to harvest it at the back end is the other questions that can come along. You can get partway into a project and realize, whoa, this is a lot more work than I thought it was going to be, or I don't have the proper equipment to really capture what I think I want to capture the answer to the question or dig into the question a little bit further. So again, I think asking yourself how you're going to get there in terms of what's needed can help quite a bit. So in the pictures that you see on this slide, we've got everything from large scale equipment that's running through a field versus an NOPP project that we've done on nitrogen optimization, where we actually dug soil pits to put some lysimeters in. And so we had to plan far enough ahead that are we going to do this just digging some random holes, or do we need a backhoe to help save ourselves a little bit of time and effort to get this done? And then that picture in the middle is more, it's a hop project where we've did some product, looked at some products, some applications, some soil management types of things. And so you can see the little randomization of treatments across a hop yard. And so it all depends on what you're trying to answer for that question and how you're going to approach and what you're going to need to dig into that implementation side once we get there. So number one for me on this section is the relationship side of it. Again, you have to have that relationship. If this is on farm and not on a research station, you have to have that relationship with the farmer and could potentially be a landowner. If that land happens to be rented, can we do this project on rented land? Is it managed completely different that we aren't going to be able to get the answer that we want or address the question that we're looking for? So again, that relationship that you have with the farmer and potentially the landowner can be a big driver in terms of how you start to set out implementing this on the ground. So to me, building that relationship, knowing a farmer that's truly interested in it, is someone that will most potentially, follow through on what you're asking them to do. And if it's simple, again, maybe that's a big component of putting that project on the ground. So again, I think the relationship's a big part of it. The other piece to this is those input and service providers. So if you're going to be doing an on-farm research, but you're going to need, the farmer's permission, or you're going to do this in a collaborative effort, but then that input or service provider that's going to apply the manure, possibly apply the fertilizer, apply the crop protection products, are they going to be on board with doing it? And so you need to have those relationships and a lot of communication. I think that's one word we're going to hear a lot about on the practical side of this, is you need to communicate quite intensively sometimes to make sure things are happening. And even then, it's not going to be a foolproof plan. But up front, I think the relationships with the farmer, the landowner, and who else is going to be involved. And a lot of times it can be that input or service provider for that farm that can be a big ally in what you're trying to do. Also know that farm landscape. I think knowing knowing the owner, is the owner make all the decisions? Is there an owner operator? Is there an agronomist that's part of this team that you're trying to work with? What about employees? Perhaps there's someone that's going to be running the equipment. So the decision is made by the owner or the operator or a manager, but the person that's going to be doing the applications or helping with tillage or running the planter, you may need to have direct conversation with that employee. In several of the projects I've done, the farmer will say, yeah, we're going to do this. But then when you get out there, you're talking to an employee who has no clue what what the project is. And you have to kind of go back to step one and start to lay out, here's what it is, and here's what we want you to do. And so sometimes you definitely have to know the farm landscape as far as how that farm operates, and also not just physically where it sits within the landscape of the field, but and also who does the farm work with or for. And so in terms of kind of back to that service provider, who do you need to ask for some of those, if there's other products and things like that that you're investigating. Perhaps you need to get permission from that farm or at least ask from that farmer, who are those input providers. So maybe you're not supposed to purchase that product from this supplier. We use this other supplier, so don't talk to them. I've got a bad relationship with them. Work with these people. So who that farm does their business with is pretty important in on-farm research, so you don't damage that relationship. So one popped a picture up here of a manure applicator. We get into some manure application research projects, and there again, that's one that working directly with that commercial or that custom manure operator can actually be the person that's going to do the project for you. The farmer might give you permission to do it, but you're going to be working directly with that custom operator. And then also someone like a land conservation department, or you might have a service that does some GPS work or some type of specific service that needs to be done. Who do they work with? Who do they want on their land? Who do they want to work with, you to work with in those situations? So again, knowing that farm landscape can help answer and avoid some of those issues that might pop up during the growing season. So getting into more the nuts and bolts part of it, the field selection, again, is another piece. Abby kind of directed us towards, trying to find that uniformity or try to avoid that variability. And we have ways in the research design to deal with that. But does that field fit the research need? If this is going to be something where it's going to be more machine harvested versus hand harvested, how does that field selection fit into the actual need? If it's a crop protection product or a fertilizer product, how does that going to get applied, and making sure that the field we're using for is going to be help us answer that question. So again, lots of different infield variability with soil type and slope and those kind of things we need to think about. And so the more uniform we have, we can start to maybe take some of that variability out of that research design. And then that previous crop history. Is this easy to obtain? Does the farmer keep good records? Do they know what happened on that field? It's good to go back 5 years. Is that where you want to look at in terms of how many years do we go back? Several of the projects I've worked on over time, it's usually going back about 5 years, especially some type of a nitrogen study or a fertility study, because was manure applied? Is there some manure crediting types of things to think about that can actually influence what you're trying to assess. And then again, that farmer relationship, back to that relationship of, can I ask these types of questions? Can I get all the history I need? And how many years of that do we actually have to look for? And so that is going to influence that large or small plot design, depending what you're asking for and what is available to be able to use on that farm. So here's just an example of a very small plot design we did looking at some dryland rice varieties with some mung growers, and they didn't have a lot of land, so we kind of pared it down to about a 10-foot plot where we looked at lots of different varieties of dryland rice that they were growing, and we basically evaluated it on a small plot design versus something like this one here, which is the nitrogen optimization pilot project, where we had a half-mile field and we have 48 different plots out there that are 24 rows wide by 400 feet long. So much different design depending on what you're trying to answer and what you have to work with. So once you have that design determined, then it's what of those samples need to be collected. So once again, going back into the soil samples, the plant tissue, the residue, The cover crops, are you going to be doing biomass? So that thinking ahead, again, getting into what do I need to be collected? Because it's easier to think about it up front versus during in the season and then having the question pop up. I wish I had sampled, collected, or tested for that. So it's after the fact, the growing season's over, and you're like, oh yeah, we should have pulled that last nitrate sample, or we should have did this mid-season. And so trying to think about as many of those types of variables that might help answer a question or take out some of that variability, or at least gives you an answer to what you're dealing with. Having that up front and thinking about it can at least get rid of some of that frustration after the harvest season's over. So the last couple slides here on thinking ahead is that proximity. All right, where is that field located? So what you have on the screen is our winter barley plots that we've done. In the upper one on the top end is 2023 planting, and the bottom towards Highway M is 2024. So the ease of scouting, data collection, general observation, and access, it's much easier. I don't know if my pointer is going to show down here, but down here by Highway M, it was much easier to get into this field, just drive right off the road, and my plot was right there. Versus this field back here, here's Sand Creek. We had to actually drive through the creek to get to this field. There's actually running water that comes through this creek. There's no bridge. The farmer has a crossing built in, basically a hard gravel crossing, and we have to drive through the creek to get to this field. So you can also think about it from a practicality standpoint, field days, those kind of things. So thinking ahead a little bit about the proximity, the ease of trying to collect that data, and then, a question with a lot of UAVs out there is, can you fly there? Is there an airport nearby? These kind of things. One of the plots I'll show you in a little bit is where we can't use a drone because or we have to get permission or let them know that we're going to just fly a few feet above the crop to get a picture because there's an airport within just a mile or two of where we're flying. So those of us that are in extension and those that have to work with extension on-farm research, we are in the education business. So again, back to these fields, is it visible? Busy roads, populated areas? Is it more remote? Can we get there? Is it going to be easy enough to collect that data and have that educational forum? So if we're going to use these plots as a learning tool, then where can we set up for a field day? How do we promote it? Can we do public relations and media types of things to get people to these fields? That field I had just shown about where to get to that, how are you going to cross that creek? We never did a field day there. We pulled it out towards the farm more and just brought some of the plants and did some general discussion. We didn't want people driving through the creek to get to the field day. So what about alleyways, walkways? Are people going to be allowed to walk through and look at things without, if it's small plot design, are they going to damage some of the plants that are out there and skew any of the data, those kind of things? What about parking, food, restrooms? And then signage is a big one. How are you going to get people there? So again, signing those plots. And we actually had this hard metal steel sign created that we basically can move around and set up at different field days just to help promote extension, but also that this is a demonstration site. If it's going to be a longer term thing, we may leave this up permanently for the whole season. So those of you that I work with or within extension, some of you call it the Jerry Clark Farm, but this is the city of Chippewa Falls. And these are my plots right here. So you talk about proximity that we are in. Right off to the side here is where you see the entryway is where I've got the little point over here. It's not the easiest field to get to. So we use this field for a lot of our plot work, but it's a little harder to get to since you got this populated area. You've got kind of a semi-roundabout to move in through here. And then you've also got this business park that's over in this area. So once again, proximity to have field days and things like that. Think about that from that educational forum piece. So what is neat? So on the implementation side then, what is needed to get the data? And sometimes you think about it working backwards. So if it's a harvest or an evaluation of, and not so much a survey, but a harvest project where you're going to take yield, maybe you need to work yourself backward. Okay, how are we going to harvest this to get the data we need? Is it machine or hand harvested to begin with? Can we get a machine in there? Can we how are we going to be able to do this? The little plots I have, it's not easy. It's not very easy to get a 40-foot soybean head into that field. And then this is obviously going to design exactly what Abby was talking about in terms of design, treatments, replications, and data collection. So consider the size of that and what's available. Are you going to have to split planters and drills or the planting equipment? Can you split them, or do you have to do one treatment and then clean that out and put another treatment in? What about crop protection products, fertilizer, manure application? All of these kind of things can drive what is needed in terms of how you're going to lay this out from a practical standpoint. So these two pictures, one is our large scale nitrogen project on the left, and then our small plot planner that we have on the right. It all depends on what we're trying to measure and what we have for seed and equipment. Some other observations, plenty of them: contour strips, wildlife damage, sensitive areas, environmental setbacks. So again, just a wider view of my little plots in Chippewa Falls. I kind of outlined them here in this green. And you could see that there's a bike trail. This is a bike trail that winds all the way along here. Lake Wasota's over here. The Chippewa River, the dam and the river runs through here. So we have to be very careful about what we're doing in there. It's an atrazine prohibited area. So any of my research cannot use atrazine. So there's certain products we can't use. So there are pesticide restrictions. Think about those setbacks. And do you need pesticide applicator training? Are there products you're going to be using, or does that farm want to look at? Does that need certification before you can apply those products? So, tools of the trade. What all do we need to get this on the ground? I think Abby had a nice picture there of some tools in the field. I just grabbed some stuff that's been in our storage area waiting to come out this spring. But thinking about all of the things that can help you, if you have it all in one place, you can pull it together and get in the field to get things done. It works a lot better. So those measuring tapes, maybe if they're large scale, you can get by with a measuring wheel, lots of flags and stakes. These plastic tubes work great for alfalfa research because you can drive them in the ground and put the flag in there. And then when they're ready to mow, you can pull the flag out, they mow over the top, and you can find your tube again to put the flag back in. Data collection, lots of different things we can use in terms of that we should have. Lots of clipboards, data sheets. You can use weather meters, or now that we have the WiscoNet running, that's another option that we can use out there to collect weather data if we don't have something real close to where we have our plots. Soil probes, bags, all the stuff that we usually use, and of course a cooler always comes in handy as well. Then troubleshooting, communicate. If you do these long enough, you're going to have plots that get destroyed. Something can happen, wildlife damage, these kind of things. A lot can happen. So this is just a screenshot I took of my cell phone a couple of years ago. We had a 15 species grass and legume mix manure application response study. It was planted in the spring of 22. And I was working with an agronomist with our land conservation department, and this was the message he sent because it was the next spring. And I took out the farmer's name, but it says the plot is tilled and planted to corn. It is gone, basically. So again, a lot of work to plant it in the spring of 2022. We had planned to get 2 years of data off of that plot and got zero out of it because we got through the first growing season and then it got tilled up in the spring of 2023. So again, a lot can happen, wildlife damage, all these kind of things. So try to communicate with those farms as much as possible. Again, weather, wildlife, misapplication, we know these things can happen. Like I said, tillage, you need to be flexible. And like Abby said, that those 4 to 6 replications, it's kind of designed for that. If you lose 1 or 2, if you only have 3 replications, if you lose 1, now you're just kind of doing a comparison. There's not a lot of statistical analysis that can be done at that point. So if you have 4 replications, you lose 1, you still got 3 to have some stronger statistical analysis done. You may have to adjust the data collection. We're not able to get this piece of it, but is there something else that we can gather from it? And then maybe some unplanned data can be collected. Again, I think you think about hail damage or something like that that occurs to a plot. Can we measure something related to the weather that's happened, whether it's really wet, very dry, if there's been some other kind of issue that's popped up? It may turn from um, a fertilizer study or a nutrient study. It may turn into a insect study by the end if there's happens to be an infestation of something, and you can start to make some observations that way. So maybe there's some unplanned data that can actually be collected. So again, be flexible in that troubleshooting part of it. So I'll just wrap up here and we'll leave some time for some questions here, but just some resources to think about to help you get these projects off the ground. There's always that financial side to it. And where the grants are out there that we can try to secure, and that can help with some interns from the labor side of it if you need help out there to get that done, and also the supplies and things to actually pay a farmer for an honorarium, these kind of things that can help through a grant. There's also community foundations that folks can use, and sometimes counties will have some dollars with their land conservation departments or folks like that. And then sponsors. Sometimes you can be able to work with financial institutions, insurance agencies that might be interested in looking at something. Obviously, cooperative seed suppliers, crop protection products, these kind of things. And then agricultural organizations. We have several in Wisconsin around the country that we can lean on and say, hey, we want to investigate this in terms of water quality or whatever we're doing on the surface of the land, but how is that impacting what's going on within the environment? So a lot of agricultural organizations and service organizations that we can lean on. And then that technical side, the data analysis side, that's where Abby comes in and her team, along with Bethany, they can help with that data analysis. And some of the labs can help with that too. So whether you're sending soil samples, some of the disease samples and things like that, whatever you're trying to do for testing, some of those labs can help with some of that technical analysis. And then the assistance part, back to the relationships. So extension educators, government agencies, we've used, excuse me, help from the DNR and land conservation departments that are interested in these kind of things. And again, students, some high school agriculture programs, FFA projects, and technical colleges can also be an avenue to get that assistance. Whether that's assistance for getting the data collected or actually implementing the project itself. So to wrap up on this section of the practical side, so be thinking ahead. Again, a lot of relationships where the field site, is it going to be a large, small plot design? The more you can think ahead, the less issues you're probably going to have. It doesn't eliminate all of them, but you may be able to eliminate some of the questions that come up at the end. And then the implementation. Do you have everything you needed to get it on the ground and up and running? So at least it's off to a good start. And then thinking about that educational component that you're going to have either during the project or after. And then again, finally, those resources that are available, whether they're financial or technical. So with that, I'm going to wrap up. I can take some questions.
Thanks, Jerry. And Jerry mentioned this, but wanted to reiterate that if you're interested in agronomic on-farm research, UW Extension's Crops and Soils program is here to help navigate the ins and outs of your project. So reach out to your local educator, reach out to myself at the Crops and Soils on-farm research program, and we can assist you navigate, the ins and outs from developing the research question and research design to all of that fun data analysis.